All right, so I got a bonus twin for you for a little extra practice. Please don't just sit here and circle answer choices. Like there's a thought process going on here. So if I look at this guy, the first thing I think is I can probably pull an 11. And hey, by God, that's one of the choices, isn't it? Because that is a partial factorization. Now, you should know how x squared minus 4 factors. It's going to take, and don't forget your 11, by the way, it's going to take an x and an x. And if I see things I can take square roots of, well, that's what I do. One of them's going to be negative, one of them's going to be positive. I might have the order a little backwards here, but that's choice 4. Hopefully you understand Roman numerals. Number 2, express 7 cubed plus 10 cubed using a pattern. Here A is 7 and B is 10. It's not a hard problem. So I'd have 7 plus 10. I'm not going to do any more math to it either. If I square a 7, I get 49. The product of 7 and 10 is 70. And if I square a 10, I get 100. And I'm not going to do any more math. All right, number 3 is also a multiple select, no partial. No more partial on multiple selects. I've been nice about that, but I'm done being nice about it. I need to figure out what I cubed to become an 8x cubed. I'm pretty sure it's a 2x. And I cube a 6 to become 216. Now remember, if you don't know what a cube of something is, you can always go to your little trusty TI-84 and you can raise something to the 1/3 power. And it is 6. So anyways, what I've learned is I've learned that A is 2x and B is 6. Like 2x, 6. That's the setup here. Now pay attention to signs too. Minus, plus, plus. Does that throw anything away? Throws away this one, that's for sure. Because that's minus, minus, plus. I need minus, plus, plus. Throws away that one. That one's plus, minus, plus. So probably have already eliminated some things. Now, when I put a 2x here and square it, I'm going to get 4x squared. That's going to throw this guy away. Now, this was a select 3. And you'll notice that I haven't even figured out how this thing factors, but I've already eliminated all the wrong choices. Haven't I? Use that brain of yours. Now, anyways, on to factoring this thing. One of the things I might do is I might pull an 8. A goes into 216 27 times. And if I do it this way, A is x and B is 3 because 3 cubed is 27. So I'd have x minus 3, x squared, I multiply them together, plus 3x, square the 3 plus 9. So that should be a choice. It's right there. By the way, when I pulled the 8, I got that one. Now, if I would approach this one from up here, like with 2x and 6, I would have had 2x minus 6. I square 2x, I get 4x squared. 2x times 6, 12x. 6 squared plus 36. And I would have gotten that one. So hopefully you're learning something about taking test skill. I didn't actually have to know how to factor. I had a formula, looked at the signs, done. Factor by grouping. For full credit, you must factor it completely. All right, so if I focus on the first two, I see that I can pull an x out of them. That'll leave me with 4x squared minus 1. And then I'm going to focus on the last two, and I can pull a 4 out of them, which will leave me with 4x squared minus 1. And what I have right now is I have the common factor, 4x squared minus 1, times the crap left over, x plus 4. But wait, there's more. There's always more. This bad boy is 2x minus 1 times 2x plus 1, because it's a special pattern. And look, 2x times 2x is 4x squared minus 2x plus 2x. They cancel each other out, don't they? Negative 1 plus 1, or times 1. Negative 1 times 1 is negative 1. And then you got x plus 4. Complete factorization. Easy peasy lemon squeezy. Use remainder theorem to determine which of the following are factors of f of x equals blah, blah, blah. So the remainder theorem says if f of a constant is 0, then x minus the constant is a factor. So let's just go ahead real quick and figure out what these x values are. Here x is negative 2. 2x minus 1 is 0. X is 1/2. Here x is 4, x is negative 4, x is 5. 2x minus 5 is a 0. X is going to be 5 halves. Now I'm going to switch over to using my TI-84, and I'm going to figure out which one of these are zeros. I'm going to plug the number in and just go to town with it. So I'm going to start off with x being what? Negative 2, the first one. I'm going to use a storage feature. Negative 2 store to x. And then I'm going to type in the original polynomial up here in the upper right-hand corner. X cubed minus 8x plus 11x plus a 20. I don't sound too hot, do I? I got a 6. What am I looking for? A 0, right? Factors create zeros. That's kind of a big thing here. Factors create zeros. And that didn't create a 0, because what I got is I got f of negative 2 was 6. So this guy's not on my list of things that are a possible factor. All right, now here's the nice thing about the storage feature. The next thing to check out here was a half. So take a half, stow x, enter, arrow up. You already typed the thing in once, don't do it again. Not a 0. All right, I got a 4, stow x, enter, arrow up, enter, enter. 96, not a 0. All right, negative 4. Surely one of these things is a 0. We'll find out, right? Nope. 5, store x. Have I got a typo somewhere? One of these things ought to be a 0. Enter, I need to fix this whole problem. Enter, enter. 160. Okay, 5 halves. This is an old twin. I don't remember anything about it. It could be okay, here's the whole problem. I'm an idiot the whole time, weren't I? That x right there, what was supposed to happen? That's right, she was supposed to be raised to the second power, so I got to do all this over again, and I've wasted a few minutes of your time. I apologize. All right, that was 5 halves. 5 halves didn't work. Let's work backwards. Okay, let's try that 5. There we go. That's one of them. Let's try that negative 4. Still a big fat no. Let's try that positive 4. There we go. There's another one. That's an x cubed, so there might be another one because it would have 3 zeros by the fundamental theorem of algebra. Algebra, bruh. Take a half, store it to x. Or that could have found them all. I don't know. I have no idea how many answers are on this one. Don't remember making it, to be honest with you. It ain't a half, and I think the first one was what, negative 1/2? No, negative 2. So back to that. Amazing what a typo will do, isn't it? Not that one. So those are the only two present, and I'll be right back. I forgot to hit play here. So I did the synthetic division. X minus 2 is possibly a factor, so x is 2. And you'll notice that I talked about there being no x's here, all right? Because there aren't any, so I had a placeholder. I did DMA, I dropped, I multiplied, 1 plus 2 is 3, 2 times 3 is 6. I added 0 plus 6 is 6, 2 times 6 is 12, negative 6 plus 12 is 6. So no, it wasn't a factor because it had a remainder of 6. And I'm sorry, but you didn't get to see me run through long division. But here's what I did. I did 2x times x squared to create a 2x cubed, and I distributed it to all 3 things. And then I wrapped before I subtracted. Negative 2 take away negative 4 is going to be a positive 2. Don't forget x squared. And I just went through all that. So sorry, I don't have enough time to redo it. All right, list the potential zeros of this polynomial. This is actually a really simple thing to do. It is factors of C sitting pretty over factors of A. Now, unless you've been living under a rock like Patrick, A is always the first number, C is the last. C is for constant, okay? So C is a 4, and its factors are 1, 2, and 4. A is 9. Its factors are 1, 3, and 9. Now, if I take everything and I divide it by 1, I'm going to get 1, 2, and 4. So I can't be choice B. And this one doesn't mention 1, 2, and 4. I can't be choice D. Now I'm going to take everything and divide it by the 3. That's going to give me a third, 2/3, and then 4/3. So those need to be showing up. So A is off the menu. And it looks like so is C. Because C didn't include the 1/3, the 2/3, or the 4/3. Now did it? Now finally, it would also include 4/3 and 4/9. Oh, and 1/9. So sorry, we'd have 1/9, 2/9, 4/9. I lost my place. Really easy problem. Super duper easy. All right, find all the zeros of g of x equals x cubed plus 8. It says go ahead and look at the graph to find the real one. This one does have some uglier imaginary answers. It'd be cool if you knew already that the real value of x was -2. You probably don't. But anyways, we're going to take a look at x cubed plus 8. We're going to do a zoom 6. The reason it's -2 is because a -2 cubed is -8. -8 plus 8 is 0. And there you go. The real one from the calculator is x equals -2. Let's do a little synthetic division. Here we've got an x cubed. We don't have any x squareds. We don't have any x's. And then we have the 8. And then we do the DMA thing. -2, 0 plus -2 is -2. -2 times -2 is 4. 0 plus 4 is 4. -2 plus 4 is -8. -8 plus 8 is 0. The remainder, constant, x squared. So, from interpretation, I have x squared minus 2x plus 4, which shall not, will not factor. Anyways, that's where your other two zeros are by the fundamental theorem of algebra. A is 1, B is -2, and C is 4. And then we're going to sing a little song. Goes x equals -b plus or minus square root b squared minus 4ac all over 2a. Inside this radical is a 4, take away 16, which last I checked was -12. So x is going to be 2 plus or minus a root of -12. Both pieces over 2. Now, the root of -12 is not, shall not ever be a real, so it is imaginary. 12, last I checked, is a root of 4 times a root of 3, so I get 2i root 3. Now, let's think about that. That's sitting pretty over 2. That's going to be the imaginary root of 3. 2 over 2 is 1, plus or minus the imaginary root of 3, because 2 over 2 is 1. So your zeros are -2, 1 plus the imaginary root of 3, and 1 minus the imaginary root of 3. Ta-da! Polynomial has 4 known zeros, -3, 5, root 2, and 5 minus 3i. What are its remaining two zeros, and what degree is the polynomial? So you may or may not remember this, but ugly roots have conjugates. You'll find that the kids who can remember that word conjugate don't miss this problem. Anyways, the remaining zeros are going to happen with these ugly numbers. The conjugate of a root 2 is a negative root 2. The conjugate of 5 minus 3i is 5 plus 3i. Now, the degree of the polynomial is based on how many zeros this thing has, at least its least degree. We have 1, 2, 3, 4, 5, 6. She shall be a 6th degree polynomial based on the information that you have before you. All right. In fact, you could even figure it out. Even if you couldn't figure out this, you could have been like 1, 2, 3, 4. There's nothing here, but there's supposed to be 5, 6. You could have figured it out, kids. All right, 11. How many zeros, real or imaginary, does polynomial 5x to the 108th have? Oh, my land, to the number of kids who will miss this. Somebody's going to pick E. Somebody always picks E. Don't pick E. Anyways, fundamental theorem of algebra says x to the n has n solutions, or n roots, or n zeros. So if this bad boy is to the 108th power, then it's going to have 108 solutions, or zeros, or roots. 12, determine the power function, real and complex zeros, and their multiplicity of f of x equals 3 times x minus 1 cubed times x plus 2 times 2x minus 1 4 times x squared plus 3. Then classify the zeros as touch, cross, or imaginary. All right, so the power function, and this one is harder than your test. I swear it is. You have a 3x. We're going to grab each factor. You have an x that gets cubed. Okay, that's going to make x cubed. You have a 2x to the 4th. See that? Oh, sorry. We have this x. Here you have a 2x to the 4th. 2 times 2 times 2 times 2 is 16. It's going to give me 16x to the 4th. And here you have an x squared. Holy moly. What do we have here? All right, we have x times x cubed, that's x to the 4th, times x, which is x to the 5th, times x to the 4th, which is x to the 9th, times x squared, which is x to the 11th. Then we have 3 times 16, which last I checked is 48. 48x to the 11th, and that was for last year's bonus twin. All right, so what are our zeros? Well, we're going to take each of our itty-bitty factors, we're going to set them equal to 0. Divide out that 3, x is still 0. Multiplicity of that guy would be the understood 1, which is a crossing because odds cross. Odds cross. 1 is odd. If you don't know 1 is an odd number, oh my Lanta, what's wrong with you? You got this guy right here, x minus 1, she's a 0. By ZPP, x is 1. Exponent's a 3, that's odd, we cross. 0, 3, x plus 2 is a 0, so x is negative 2. Multiplicity is an understood 1, that's a cross. Need more room. Here you're sitting at 2x minus 1 is a 0. We add 1, 2x is 1, we divide by 2, x is a half. So that's a 0. The multiplicity is 4, which means we touch, because evens touch. Odds cross, evens touch. All right, the last two zeros happen at x squared plus 3, which, by the way, see that exponent that's understood to be there? They both happen one time. It's about the exponent of the factor that does it. We set it equal to 0. We subtract 3. The opposite of squaring has always been square rooting. And the square root of a negative is not real. It is imaginary. So we have the imaginary root of 3 and the negative imaginary root of 3. And those are both imaginary. 13, the graph of a polynomial has 129 turning points. What is the least degree this polynomial could be? So turning point theorem says the degree of the least degree of a polynomial is the number of turning points plus 1. I used to say TP plus 1, toilet paper plus 1, but nobody ever got that. So 129 plus 1 is 130. I'm going to stop here. Almost done, though.